Assalamualaikum and hi, my name is Muhammad Shahrim Suhaimi.
Hi, my name is Ahmad Fadizah bin Sharamli and my student ID number is 2019407612.
Assalamualaikum everyone, my name is Putra Faizi Azim bin Azman, and today I would like to show to you guys about our experiment, which is flywheel apparatus. Let's go.
From the result of table, the time taken for the load to reach minimum point and the moment of inertia differs from the theoretical with the experimental values. This happened because when calculating for various values such as angular acceleration and linear acceleration, the values are rounded off frequently. This causes further and further inaccuracies as more rounding off occurs. The first one is parallax error when taking the measurement, and the second one is irregularities on the axis surface such as thrust might have changed the final measurement. And 3. The way the measuring tape is laid onto the axle could have been improperly placed. And finally, human error when recording time.
From the result obtained, the drop time have a different value because human error, which is time for stop the stopwatch, is not accurate. For the value of moment of inertia, experimental and theoretical, they had a small difference in value because when calculating the of various values such as angular acceleration and linear acceleration, the values taken is frequently run off, so the value will be different. The first one is faulty apparatus such as rusty axle. Next, I is not perpendicular to the reading scale while measuring the diameter of wheel and axle. Next, the used load is not accurate as it stated. After that, human error, which is timing for stopping the stopwatch, is not the same. And lastly, miscalculation and inaccurate counting of the number of rotation.
The time taken for the load to reach minimum point and the moment of inertia has a difference from the theoretical with the experimental values. This is because when various values such as angular acceleration and linear acceleration is being calculated, the values are rounded off frequently. This causes further inaccuracy. The apparatus used may be in a rusty condition. Eyes are not perpendicular with the measurement scale. Human error can be happen during the time taken. And the last one is measuring tape move during the measurement process is run.
Conclusion that I can conclude from this experiment is that the flywheel experiment helps verify the Newton's second law for rotational motion, which is equation is m equal to I alpha. From this experiment, the moment of inertia can also be determined through the use of various equations. The frictional moment that is required to overcome the friction can also be determined through this experiment. Various equations can also be used to determine the theoretical equations. This experiment shows how mass relates with time taken for the load to reach the minimum point from the results recorded in the table. It shows that the higher the mass of the load, the longer it takes for the load to reach the minimum point. This is due to the relationship of I equal to mr square, which as m increases, I also increases, and from the equation alpha equal to m over I. Alpha decreases as I increases, and as we know, alpha is inversely proportional to time. The higher the mass, the longer the time taken for the load to reach minimum point. So that's all.
From this experiment, I can verify that Newton's second law for rotation used in calculating the experimental value of moment, which is moment equal to moment of inertia multiplied by angular acceleration. This helps me on finding the moments for each load. I also obtain the moment of inertia of disc and axle by finding the mass for disc and axle, then multiply it with the radius of each object, power of 2. Thus, the value of the moment will be increased if the value of angular acceleration is increased.
In conclusion, we are able to verify Newton's second law for rational motion. We are also able to determine the moment of inertia of a disc and axle from this experiment. We can determine the frictional moment required to overcome the friction, and the last but not least, we are able to determine the moment of inertia of a disc and axle using theoretical equation.
Thank you.
Thank you.